All right, this will be the third and final video that deals with adding vectors. It's going to be the same softball, same wind, same everything. So hopefully our answers will again be the same as they were before. 50-ish miles an hour, 23-ish degrees east and north. What I'm going to do is show you how to use this or how to answer this using what I jokingly call left triangles. It means they're just not right triangles. Doesn't make them wrong. It just means they're not right. Okay, so what I'm going to do is sketch them and put them tail to tip, and I will then use the law of cosines or the law of sines, depending upon what we know and what we don't know about that triangle. So, first one I'm going to do, 60 miles an hour, 35 degrees east of north. Again, this one doesn't have to be to scale. Just pick something and say, okay, that, and the angle I know is this one, 35 degrees. Again, that's east of north. Tail to tip to that one, 15 miles an hour, 10 degrees south of west. So this is starting out looking very, very similar to the tail to tip the graphic method, but again, I'm not drawing it to scale. I'm just using this as a reference to build a triangle. So I'm going to end up going somewhere over there. That angle is 10 degrees. Okay, so my resultant now is always from the tail of where you started to the tip of where you ended. So this, boom, from there to there, that is the R, and that is what we are looking for. This one we said is 60 miles per hour. This one we said is 15 miles per hour. So I want to know how big that line is. And we can use triangleology. We just can't use right triangleology because that triangle ain't right. Doesn't make it wrong. It means it's left. So what I need to do is start seeing if I can fill in values for some of the angles we can use. I know 2 of the 3 sides. This is the one I'm looking for. So if I can get maybe what that angle is, or what the angle between the red and the black line is, or maybe this angle here, I could know 2 sides and 1 angle. So what I'm going to do is see if there's one of these angles I can figure out here. This one, or it's going to end up being this one. And the way we know it's going to be this one is if I redraw this black north-south dotted line, and I redraw it right here. Then what I have is the first vector that I drew is a diagonal between 2 parallel dotted lines that are referencing between, the north-south. So this line is the north-south line, so is that one. Our first vector is going across them, and I know that angle is 35. So what they call alternate interiors, that means this angle here is also 35. So it's 2 parallel lines bisected by that black first arrow that I drew, okay? Now, again, the difference between south and west, is 90 degrees, and of those 90, 35 are occupied by the angle I just figured out, and 10 of them are occupied by the angle that was given in the problem. So if I take 90 and subtract 10, I'm at 80, and then subtract another 35, I'm down to 45 degrees. So the angle that is right there, that angle, what I will draw, I guess, with the green line, this one right here is 45 degrees. All right, so figuring out what one of the other angles are is usually the hardest part for this type of this type of strategery for solving a vector addition problem when we use law sines, cosines, whatever. So now what I know is this side, I know this angle, and I know that side. What I'm looking for is the side that is opposite the angle that I know. And if that's the case, that works out pretty darn good, because if you remember, this is side angle side, and you may remember this phrase from a math class, that's some SAS, side angle side. That's an indicator we're going to use law of cosines, where we have it takes place in the Pythagorean theorem where a squared plus b squared equals c squared. So I will write that. C squared is the same thing as a squared plus b squared. Now this is what you're used to knowing is the Pythagorean theorem. It's actually a shortened, condensed version of a larger version where from this quantity we subtract 2ab, meaning the sides, a times b, multiply that by the cos of angle C. All right? So the one angle that I know, I'm going to have to label angle C. So this 45-degree angle, I'm going to call angle letter C. When you label triangles, opposites are clearly the same. What that means is this angle is opposite that side, which means they are going to be labeled with the same letter. So opposites are clearly the same. So if that's angle C, that's got to be side C. And then the other twos that are A's and B's don't really matter. If I call that, for example, angle A, if that's angle A, opposites are labeled the same. So this is going to be side A. And then that means this could be angle B, which means this could clearly be side B. See? All right, so that's labeled. We can now start putting values into here and just push the square root button and we can see what value that resultant vector is. So A is what we ended up calling 15. All right, so this A is going to be 15 and I'm going to square it, plus B, which was this 60, and I'm going to square it. I'm going to subtract from that 2 times 15 times 60 times the cosine of 45 degrees. And all of that is going to be square rooted. When you type and you push the second square root button, the calculator will give you a parenthesis there. Use it. 15 squared plus 60, the calculator will know to go ahead and do all of this math before it pushes the minus and the plus button. So the only other thing you need is a parenthesis at the end. It will open a parenthesis right there as soon as you push the cos button. So if you want, you can close 2 sets of them. But if not, the calculator will still know to tell you what C is. So hopefully, since we already did all of these, using the tail to tip and using the components, when I push this, hopefully my answer is dancing around 50. So I'll push the second square root. 15 squared plus 60 squared minus 2 times 15 times 60 times the cos 45, close the parentheses, and I'm getting C to be 50.5, which is outstanding because if you remember, that's what our answer was when we did the component method earlier. So 50.5 miles per hour. That is what R is. So now I can label that. This side is 50.5, sorry, 50.5 mph. All right, so now we're still not done yet because what I know is just the magnitude. I don't know a direction yet. The angle that will be able to tell me what direction this is pointing is not 35. I will use 35 in conjunction with it, but what I'm going to do is I'm going to see what is the angle between this red line and that black line, the 50.5 mile an hour resultant and the 60 mile an hour component. I'm going to see what this angle is that I'm highlighting in blue. In order to get that one, what I'll be looking for is if I know an angle and a side opposite it, and another angle and a side opposite it, or another angle and a side opposite it. So now what I'm doing is making ratios, and what's perfectly rational when you make ratios, that's then the law of sines. So I'm going to erase this so I can have a little more room on the board to push law of sines. And that green angle is what I'm looking for, green letter A, sorry, labeled with the blue. So I'm going to use angle A to help me figure out what direction that red line is pointing. So what I will say is the sine of A divided by the side opposite that angle, A. That's going to be the same thing as the sine of angle C divided by the side opposite C, which is what we just found out using the law of cosine. So that's going to be the same thing as the sine of C over side C. And now to then solve for what angle A is, I'm going to multiply both sides by lowercase a and take the inverse sine of all of that. So angle A is going to be the inverse sine of this little a multiplied by the sine of angle C divided by side C. So all of that is what we will push. So it'll be an inverse sine of lowercase a, which is 15 miles per hour. 15 times the sine of angle C, and angle C is what we spent some time at the beginning to figure out is 45 degrees. From that, I will divide by side C, which is the one we figured out as our resultant, which is 50.5. Okay? Now, when you push this, push the inverse sine button first, it'll give you a parenthesis. Keep the 15 times and then use the sign. It will give you another parenthesis, 45. Close that one parenthesis to tell the calculator you're done taking the sine of an angle. Then push the divide button, 50.5, and then close your original parentheses out to tell the calculator you're done taking the inverse sine of something. So again, do this math all at once. So I'm going to push second sine. So now there is an inverse sine. It gave me that parentheses. It's 15 times sine 45, and I'm going to close that one parenthesis, push the divide button, 50.5, and now I'm closing that parentheses to tell the calculator I'm done taking the inverse sine. And I'm getting 12.1 degrees. So this then, angle A is 12.1 degrees. What that means is the angle between the red line and the black line, 12.1 degrees. That's not our final answer though, all right? Because if you remember, we were dancing around a 20-ish degree angle. The way we get that is we say, well, gosh, the angle between due north and the black line, which is the original angle that the ball was hit, is 35. So that angle is 35 degrees. The blue angle we just figured out between the red one and the black one is 12.1 degrees. So if I just push the minus button, what I'll be left with is the green angle right there, which is the angle that the red line is relative to due north. So 35-ish minus 12-ish. It ain't going to be perfect. I'm going to call it 23-ish degrees, 22.9, whatever you care to call it, ish, 23-odd degrees, and that is east of north, E of N. And that number is very, very similar to the number we got using the component method. It's very similar to the number we got using the tail to tip method, the graphic method. So again, this is using law of sines, cosines. It's just what I call left triangles. The hardest thing about it is figuring out what some of the angles inside the triangle are relative to north, south, east, west, and using, in this case, we just use the alternate interiors. The fact that that full angle is 35, that means that's 35. Somehow figure out that that interior angle is 45. And then you have a side, an angle, and a side. Use law of cosines in that case, and then use that in conjunction with law of sines, where you have angles and sides opposite one another that make the ratio. So, 3 different ways of answering the same question. Yay, physics, huh?